So this section is on the Pythagorean theorem. So that is a squared plus b squared equals c squared. And we use this when we have a right triangle. So the two sides that meet together at that right angle, these are called legs. And these are the A and B. The order doesn't matter because we're adding. So sometimes we see it as leg squared plus leg squared. And then C is always this one across from the right angle, and that one's called the hypotenuse. And that's always C. And it's always the longest side. Okay, so let's jump into our actual problem and we'll use this. So we have a triangle where Z is a right angle. So Z, and then the other sides are X and Y. So X, Y, Z, where X equals 9. So this is something else. If there's an angle X, the side across from it is side X. So that's 9. Z, so angle Z, the side across from it is side Z. That's 20. We want to find the other leg. So remember, leg squared plus leg squared equals c squared, which is the hypotenuse. For this one, it's 20. It's across from the right angle. So I'll call this X. Oh, we already have an X. I'll call it Y. It is Y. It's across from Y. So Y squared plus 9 squared equals 20 squared. And now we'll solve. So Y squared, I'll write out the step. We're going to subtract the 9 squared on both sides because we want to get Y squared alone. So 20 squared minus 9 squared is 319. But we don't want Y squared, we just want Y. So we're going to take the square root of both sides because that's the opposite of a square. That's going to get Y by itself. And then the square root of 319 is 17.86. Okay, using the Pythagorean theorem, if in a right triangle leg A equals 6 and hypotenuse C equals 21, what's the other leg? So in the right triangle, the hypotenuse across from the right angle is 21. One leg is 6 and the other leg, we don't know. I'll call it X. So we have X squared plus 6 squared equals 21 squared. And it's just like last time, we're going to solve it. Minus 6 squared on both sides to get X squared by itself. 21 squared minus 6 squared is 405. But I want X, not X squared. So to get rid of the square, I take the square root of both sides. Square root of 405 is 20.12. Okay, find the length of the diagonal of a rectangle whose dimensions are 10 by 7. So when you have a rectangle, the diagonal is the line that runs corner to corner. And what it does is it makes a right triangle. Because that's a right angle if it's a rectangle. So if this is 10 and this is 7, those are the sides of the rectangle, we want to find the length of this, which happens to be a hypotenuse of a right triangle. So I know the legs. 7 squared plus 10 squared equals c squared, and now we don't even have to solve because c is already by itself. So 7 squared plus 10 squared is 149. And then to get rid of the square, we take the square root. The square root of 149 is 12.206. Oh, round to the nearest hundredth. 12.21. That's tricky. That's rounded to the nearest 10,000. Okay. Tell whether the given lengths can be the sides of a right triangle. Okay, so if I have a right triangle, the longest side is C. So in this one, 4, 5, 2, it would be 5. That means 4 and 2 would be the legs. So I'm going to use the Pythagorean theorem and see if this is true. If it is, the answer is yes. If it's not, the answer is no. Okay, so leg plus leg, 2 squared plus 4 squared, and then C is the hypotenuse is 5 squared. So let's calculate that. 2 squared plus 4 squared is 20. 5 squared is 25. So because these are not equal, it's not a right triangle. So we can use the Pythagorean theorem to check and see if something's a right triangle. In triangle ABC, leg is 17, hypotenuse is 26. What's the other leg? That's what it's asking. So leg squared plus leg squared. Let's call this leg x. Equals hypotenuse squared. I'm going to get x squared by itself. I'm going to subtract 17 squared from both sides. 26 squared minus 17 squared is 387. And then we're going to take the square root of both sides. So x equals square root, 387. So 19.67. When it doesn't tell you to round to anything, round to the nearest hundredth. So that means 2 numbers after the decimal. Okay, so this one's the same. We have a leg and a hypotenuse, and we're trying to find the other leg. Okay, so one leg is 17, the hypotenuse is 25. What's the other leg? I like to just have them equal. So 17 squared plus x squared equals 25 squared, and I'm going to sum for x. So minus 17 squared. Square root both sides.